Hey guys, in this section today we're going to be talking about solving logarithmic equations. Let's first define what a logarithmic equation is. So a logarithmic equation is one in which the variable occurs in the logarithm. So for example, when you have natural log of x plus 2 equal to 5, or if you have negative 10 plus log base 3 of n plus 3, so your variable's in your logarithm there. Or you can have a variable in two separate logarithms, but it's still in a logarithm, at least one. So this would be a logarithmic equation. There are some guidelines for solving logarithmic equations, similarly to how we solve exponential equations. So first thing you have to do is get the logarithmic expression on isolated, excuse me. So for example, the first one, my logarithm of x plus 2 is by itself on this side. There is nothing like I'm not multiplying it by 2. I'm not dividing it by 5 or anything like that, right? It's just a logarithm. In this scenario, I would have to deal with the fact that I have this negative 10 being added to this log first. I would need to get rid of that in order to get this logarithm by itself. And then on this side, I would actually have to combine logarithms first, which is why we learned properties of logarithms before we tried to solve these, okay? So once you have isolated the logarithm, basically you raise the base number to each side of the equation and then cancel out your logarithms. I'll show you what this means. And then you solve for your variables. So for example, in this natural log of x plus 2 equals 5, the first thing I check is, does it isolated? Is my logarithmic expression isolated on each side of the equation? Well, my right side doesn't have any, so just my left side. Yes, my logarithm is by itself. Then I'm going to raise the base number. So what's the base of this logarithm? Well, hopefully remember the base of any natural logarithm is the secret base e. So what I'm going to do is I'm going to raise e to both sides of this equation. So I'm going to do e to the natural log of x plus 2. And then I'm going to do e to the 5th power because I'm using this base and I'm raising both sides. Kind of like if I had an x squared, I'm raising x to the 2nd power. So in this case, I'd be raising the base to each side of my equation. Okay. Now that I've done that, what you can do now is, as long as your natural log was alone originally, my exponential function here, my e and my natural log, cancel out, and I'm left with x plus 2 equals e to the 5th. And now you can go ahead and just start solving for x. So then I'll subtract 2 from both sides, and then in my calculator, I can actually do e to the 5th minus 2 and get a number rounded to 3 decimal places. So if I have e to the 5th minus 2, I should get 146.413. Voila. All right, so that's one example. Let's go ahead and try another one. So in this example, I have my logarithmic expression with my variable in it. It has negative 10 being added to it, so what I'm going to do is I'm going to add 10 to both sides to get rid of that first. So I have the log base 3 of n plus 3 equal to negative 10 plus 10 is 0. And so now my logarithm is isolated on one side, or on each side of my equation. I don't have a logarithm on that side, but that's okay. And so now I'm going to take this base and I'm going to raise the base to both sides of my equation. So I'm going to take this little 3. I'm going to do 3 to the log of n plus 3. And on this side, I'll do 3 to the 0 power. So you see how this side of the equation pops up into the exponent, and this side of the equation pops up to the exponent on this side. All right, so then my 3 and my log base 3 cancel out, and I'm left with n plus 3 equals 3 to the 0 power, and then I can subtract 3 from both sides. So then I'll have, n equals, well, what's 3 to the 0 power? 3 to the 0 power is 1. Anything to the 0 power is 1. And 1 minus 3 equals negative 2. All right, for this next example, we have multiple logarithmic expressions going on. So I have one isolated on the right side of my equation already. So I need this to be just one logarithm on this side. So what I'm going to do first is recognize, hey, when I have addition between two separate logarithms, I can combine those into one logarithm that contains a multiplication. So I'll have x plus 6 times x equals log base 9 of 27. If you wanted to go ahead and distribute that x, you can. I'm going to wait and do it in a minute. So now on the left side and right side of my equation, I have one logarithmic expression on each side, so we're good to go. So now what I can do is I can take this base and I can raise this base, to both sides of my equation. So 9 to the log base 9 of x plus 6 times x. And then on this side, 9 to the log base 9 of 27. Again, identifying how this was the right side of my equation, and now it's an exponent on a 9. This was the left side of my equation, and now it's an exponent on a 9 as well. And so then now we can go ahead and on this side, my log base 9 and 9 cancel, and they actually do it on this side too. That's really nice, because now I'm left with x plus 6 times x equals 27. And now I can start solving for x. So go ahead and distribute. And I have x squared plus 6x equals 27. And now I have a quadratic equation that I have to solve. And how do we solve quadratic equations? We get them set equal to 0. So maybe make a little note for yourself. Correct handwriting. Solve equaling 0, right? So now I'm going to get it to get equal to 0, so I'll subtract 27 from both sides. Oh. So I get x squared plus 6x minus 27 equals 0. This is a quadratic. I don't have any greatest common factors, and I have a value of 1, so I'm just going to go ahead and factor. So I figure out what multiplies to negative 27 and adds to a positive 6. That looks like it'd be a positive 9 and a negative 3. Cha-ching. So then we get x plus 9 x minus 3 equals 0. And then from there we can find our two solutions by separately setting them equal to 0. Now, so my answers are going to be negative 9 and positive 3. And then the last thing you have to check with logarithms, you have to check for, I guess, negatives in the log. So if I have two solutions here, and the one thing you have to check is that if I plugged these solutions back into my original equation up here, at any point would I have a negative number inside of a logarithm? Because if that is the case, then basically what happens is that becomes an extraneous solution. Which means it's one that we found that was possibly going to be the answer, but then turned out not to be because it didn't make my original equation too. So x equals negative 9 and x equals 3. If I plug in 3 into this equation, I'd get 3 plus 6, and that's a positive number, so that's fine. And if I plug 3 into this logarithm, I'd get a positive number, so that's fine. But if I plugged in negative 9, I would end up with negatives in both of these logarithms. So this is actually an extraneous solution. It doesn't make your equation true. And so the only answer is x equals 3. All right. So now we're going to go ahead and do the same thing with example D. And then we're probably going to have to double check the same thing if you end up with a quadratic and multiple solutions. If you end up with one solution, then your answer is just that one. All right, so it looks like I have natural log of 4x plus 1 minus natural log of 3 equals 5. I don't have a logarithm on the right side, so I'm going to have to just combine these two on the left-hand side in order to isolate the logarithm. So if I have natural log of 4x plus 1 minus natural log of 3, that can turn into division inside of one logarithm. So 4x plus 1 divided by 3 equals 5. And then now, what's the base of my natural log? Well, it's secretly an e, so I'm going to take that e and I'm going to raise it both sides, raise that e to both sides of my equation. So e to the natural log of 4x plus 1 over 3, and then e to the 5th power. So on this side, my e and natural log cancel, and I'm left with 4x plus 1 over 3 equals e to the 5th. And so then I can go ahead now and I can just start solving for x. So I can multiply both sides by 3 in order to cancel out with this division by 3. Then I have 4x plus 1 equals 3e to the 5th. Then I'll subtract 1 from both sides. Oops. And then I'll divide both sides by 4. So in your calculator, go ahead and write that our x equals whatever all that stuff is. So if I do 3 times e to the 5th power minus 1, and then I divide that answer by 4, I ended up with 111.060. Beautiful. So that is how you solve logarithmic equations. The trickiest one for sure is a problem that ends up with a quadratic because you just have to do an extra step. But this is actually awesome because this will be good practice for when you take your Unit 2 test and have to remember how to solve quadratic equations. Okay. Let me know if you guys have any questions.